Okay, welcome back. In example 3, we're going to be finding limits by looking at the table of ordered pairs and write a limit statement then that can be modeled by the data in the table describing the asymptote of each function then with that limit statement. So when we look at this first table, we see that the x values are going from -3, negative 2.999, negative 2.99, negative 2.9, where the x values are, if we look from the right side toward the left side, these are approaching -3. And we see that at -3, the function is undefined. And that usually occurs when there's an asymptote, a vertical asymptote there. So as we come from the right side towards -3, we see the y values are getting bigger and bigger. At first, that distance between them is pretty big. From 2 to 5 is a difference of 3. From 5 to 10 is a distance of 5. From 10 to 100, that's a difference of 90. And then from 100 to 1,000, right, we can see how this is getting really, really steep as we come closer and closer and closer to that asymptote. So that means that the limit as x approaches -3, and we're getting from positive infinity towards -3, so we're getting there from the right side. We put a plus as the superscript of our function, and this function is f. That limit is going to head up to positive infinity. Right? The limit does not exist because there's a vertical asymptote here at -3, but we can see that the curve is going to bend and quickly get very, very, very steep very quickly. So that's approaching positive infinity from the right. When we look at the second table of ordered pairs, now our x values 1, 5, 10, 100, 1,000, our x values are headed toward positive infinity. We're getting bigger and bigger and bigger x values. So this is the limit as x approaches positive infinity. And that's the right end behavior for the function g of x. Now let's look what the y values are doing as these x values are headed to infinity. We're going from 4 to 3.2, so we're going down. Then 3.2 to 3.1, that's flattening out. 3.1 to 3.01, then to 0.01, we're approaching closer and closer and closer to 3. That's our horizontal asymptote, which would be the limit as x approaches infinity.